Okay, well, let's see if we can squeeze the last 4 into the next video here altogether. Okay, so for this function here, we're supposed to find for what values of x is f prime of the function equal to 3. So the first thing we need to do is draw the f prime of this. The f prime of x equals, of course, by the power rule, 3 times 4/3 is 4x, and then the square goes up there, right? Plus 2 comes down, that's 22x, plus 10. So now we're going to find the value for that of where it equals 3, value for x where this equals 3, and that is the same as 0 equals 4x squared plus 22x plus 7, right? Minus 3 on both sides will give you plus 7 over here. And now on this one, I personally prefer to divide that by 4 both sides so that I get an x squared without a coefficient. But you can also insert these values directly into why don't we do that? Why don't we do it the way that I'm not so comfortable with, to just see and prove that you might be comfortable with that and be just fine with it. So what is the quadratic equation here? It is negative b, right? B is 22 in this case. 22 plus minus b squared, so that is 22 squared. That's 22 squared. Minus 4ac, so that's 16 times 7. I almost need to break out a calculator here to do these things. Well, so why don't we do this on the side margin here? So 16 times 7 is 70 plus 42, that's 112, right? 70 plus 42 is 112, yes. So that is 112 right here, so minus 112. And then this whole thing over... 14. Number 14 is kind of on the brink here. Sorry about that. And then that whole thing over 2a, 2a, a is 4, 2a is 8. All right. Okay, well, good enough. Now, let's see what happens next here. So 22 squared, what's 22 squared? Hi, now you're making me really think hard. So let's do 22 times 22. That's 44. I'm doing this the German way. You might go like, what are you doing? Okay, it's 484. That should be 22 squared. 484. Yeah, so 484. So 484 minus 112 then is 112. Oh my wordy. Okay, that's 2. That's 7, and that is 3. 372. Golly. Okay. Okay, I bet you I can factor something out of this. How about 4? So that'd be 4 times what, 93? Yeah, 4 times 93. So I can take 4 out of that square root. So that's right again here. So it's negative 22 up here plus minus 4. 4 comes out of the square root. And this here is then going to be 93, right? Over 8. Then I'm going to reduce this. This is going to be 4. This is going to be 1. And this is going to be 11. Right? Reduce it by 2. So that gives you then minus 11 plus or minus the square root of 93, and the whole thing over 4. Okay, because you have the plus or minus, you have the 2 values of x here. So x1 is minus 11 plus square root of 93, the whole thing over 4, and x2 is minus 11 minus square root of 93, the whole thing over 4. Bam! That's number 17. Okay, what's 18? 18 is another product formula, product rule. Okay, find the value of x where x2 prime of x equals 0. So let's find the prime first. F prime would be the prime of the first factor, which is 4x cubed, times the second factor, plus this first factor, which is x4, times the prime of the second factor, which is prime of the second factor. Prime of e to the x is e to the x. Okay. Now again, we're looking for the second prime, just like in one of the other problems above. I would, in this case, not factor out e to the x because that's going to deal you a chain rule problem. But instead, I would just use the product rule twice on these terms. So the first time is the prime of the first term is 2x squared times the second term plus the first term times the prime of the second term, and that deals with this first term here, right? First factor, okay? And then plus, now I need to do the same thing for this, so the prime of the first factor times the second factor plus the first factor times the prime of the second factor. Okay, and there you are. So find the values of x where this whole thing equals 0. So I think it might be worth factoring out the e to the x in this case. Okay, so let's do it. E to the x times 12x squared plus 4x cubed plus 4x cubed plus x to the 4. Okay, combine these guys here, they're like terms, so it's e to the x times, well, let's pull the squared in the front, so that's what, 8x cubed plus 8x cubed plus, what is that, 12, right? Yeah. Oh, actually, the x to the 4 should be even before this whole thing. Let me erase until I got there. Okay, so x to the 4 plus 8x cubed plus 12x squared. Well, now since I'm looking for 0 crossings, I know this is never going to get 0, right? This is always at this is always going to be greater than 1. Let's see. So let's see. So this here is now my f2 prime, right? So we're looking for where is f2 prime equals 0. This is never going to equal 0, so I have to turn this into factor this guy here and see how many factors there are that may each individual factor turn into 0, and then those would be the values for x. Okay, so 0 equals e to the x, and now let's just factor this guy here. We don't even need that because we're going to have factors. So one factor is x squared in here, right? X squared is going to be in here. And then what? So I have x squared that makes this into x squared plus 8x plus 12. Okay, 8x plus 12. So it's actually going to be this and this. Okay, right? Because 2x plus 6x is 8x, and 2 times 6 equals 12. Okay, so these are the factors of this this thing here. So it's x squared, x plus 2, x plus 6. So each one of these factors could turn into 0. This can never turn into 0 because e to the x is always greater than 0. X squared turns into 0 at x equals 0. This factor here turns into 0 at x equals -2. And this factor here turns 0 at x equals -6. So these three guys here are your answer. Pushing right along, that was, what was that? That was 18. Find an equation of the tangent line to the curve y equals e to the x times x plus 1 at x equals 0. This is can be a simple problem if you just find first, you make this the point, right? So why not find the y coordinate of this point? So we have a simple structure problem like we had before. What is the y coordinate of this function for x equals 0? E to the 0 is 1, 0 plus 1 is 1, 1 times 1 is 1, so it's 0, 1. This is your point, okay? Now you just use that formula here, y minus the y coordinate of the point equals f prime. We're looking for tangent line, right? Not the normal line. F prime times, not f, so f prime of, let's see, sorry, f prime, I should write f prime of 0, f prime of the point, right? Times x minus the x coordinate of the point. That's the formula, okay? So I got everything. I just have to find f prime of 0. So what is f prime here? I have, again, a product, so I'm going to use the product rule. So f prime is going to be the derivative of the first factor times the second factor plus the first factor times the derivative of the second factor, which is just 1 in this case, right? So that is my prime. Factor out e to the x, so it gives me e to the x times x plus 1 plus 1, or e to the x times x plus 2. And now I plug in 0, right, because I'm looking for f prime of 0. So f prime of 0 then equals 1, right? E to the x, e to the 0 equals 1, times 0 plus 2 equals 2. So it's 1 plus 2, so it's 2. Okay, plug this back into your formula, into the tangent line formula, so it's 2. And then here there's just x because it's 0, right? So there you go. Y equals y minus 1 equals 2x. And you can leave it like that. Or you can turn it into the slope-intercept format of this formula as well. But you don't have to. There you go. That is the solution to number 18. Well, actually, you weren't even supposed to. No, hang on a second. Where are we? That is not that. This is 19. Sorry, this is 19. So find an equation. So yes, that's that here. The box thing here is the solution. And number 20. To find an equation of the tangent line of the curve, blah, 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 at x equals 1. Same exact steps, maybe slightly more complicated function, depending on how you feel about this thing here. So, and this would require, obviously, this is a quotient, so it would require the quotient rule, and possibly the chain rule inside this thing. So it's a little bit more involved, but only in terms of finding the actual derivative of the function, and then finding the derivative, the value, the slope of the tangent line at that point right here. Okay, so let's do it. We're going to use the same tangent line formula with y equals the y coordinate of the point. So let's just find the y coordinate of the point first. The point is 1. Now let's plug 1 into this equation. That gives you 4 on the top, and here is 3 plus 1 is 4. The square root of 4 is 2, so it's 4 over 2. So that makes that 2, right? So this is the point here. That's the point that you're looking at, 1, 2. And now we just have to find f prime of this thing. And this is an x, right? So how do we go about it? It's f prime times g of x f prime, this is a 4. This here, my friends, is a 4. Okay, so minus f times g prime. Now g prime might be looking at you like a little bit more involved. So let's just see. Let's work from the inside to the outside, right? G is on the bottom here, and that is the square root of u, and u equals 3 plus x squared. So the square root of u, the derivative of that is 1 over 2 square root of u, and then I just insert this thing here back into u, which is u, 3 plus x squared, so hard to read, and then times the derivative of the inside, which is just 2x, okay, and then the whole thing over the square of g, which is just 3 plus x squared. There. Okay, now let's sort this out a little bit. I wouldn't even bother sorting it out too much. So this is just going to be, I'm just going to insert 1 here, right? Because all I'm really interested in is the value. So I'm just going to go for it. I'm not going to look to clean up this function all that much. Just going to plug in 1 for x and see what happens, right? So 3 plus 1, I'm not going to even use a square root here. So 3 plus 1 is 4, the square root of that is 2, so this here is my value, a minus. Then I have minus 4, this inserts, and then so this is x, it's 1 over 3 plus 1 is 4, square root of that is 2, 1 over 2 is 1 over 2, and then this whole thing over 4, and I reduce the 4's, and I'm left with, this is a times, this is a dot, and this is a negative sign, minus sign. So 2 minus 1/2, and that is 3/2. All right. So that is what? That's the slope. That's the slope. Now I'm inserting the slope into my tried and true formula, which is y minus the y coordinate of the point equals the slope times x minus the x coordinate of the point. And this, ladies and gentlemen, is it. And that concludes the test results.